हरिः कर्ता।
Now let's move to the step 2 under feature relationship analysis, which is visualizing correlation matrix. So we have made a correlation coefficient matrix in our previous slide. Now it's time to visualize that correlation coefficient matrix so that interpreting that would be much easier than simply going through the numbers, because this differentiating the colors is much easier than differentiating the decimal numbers. That's what the human psychology is. So that's the reason visualizing the correlation coefficient matrix will be done now. So correlation matrix is a table that displays the correlation coefficients between all pairs of features in a data set. So it provides a comprehensive view of the relationships between features. Heat maps are commonly used to visualize the correlation matrix, and heavily heat maps are the most commonly and heavily used to uh, visualize the correlation matrix. So where the colors represent the magnitude of the correlation coefficients, this helps identify highly correlated or anti-correlated features. So let's take this data set as an example. It's a Titanic data set. Everybody knows regarding this data set. If you are a data scientist, you would have known about this. The Titanic data set contains records of the passengers on the famous ship. So RMS Titanic. So each record captures some information about a passenger like ticket class, age, sex, etc. So there is also a Boolean field determining if that particular passenger survived the historical accident. So let's take a look at the correlation matrix with a few relevant features we used with the following variables. And the variables that you can see on the screen here: survived, P class, sex, age, and patch, SIB SP, that's of siblings or spouses aboard the Titanic. Parch, it's basically of parents or children aboard the Titanic. And fare, passenger fare. And obviously survived is dichotomous or binary variable. And P class is categorical variable. Sex is also a dichotomous or binary variable. Okay, so this is our data set, and we have calculated the correlation coefficient matrix. Then we have created heat map to visualize that. And here clearly you can see that the ones which is of same class, survived, that you should not consider. You have to neglect it. So other than that, the highest color from 0.6 to 1.0 is blue to dark blue. So I have to look for the dark blue. So I do not have any dark blue. I have the light blue. Light blue is between 0.4 to 0.7. So 0.55, 0.55, 0.3, 0.54, 0.54. These are some extent they have a good correlation. It's moderate correlation. On other side, the one, these are -1, -0.2, -0.4, -0.6, -0.8. These are negative correlation or anti-correlation. That's what they say. So negative correlation. So from -0.6 to -0.1 -0.6 to -0.8 -1.0. These are from light blue to dark blue, and their negative correlation strength is high. And On the other side, if it is a red color from zero point 0.6 to 1.0, so the positive correlation strength is higher. And other than this survived to survived, so we don't find much of positive correlation. Everywhere you will find negative correlation, that too a good negative correlation and moderate negative correlation. So let's see the following figure shows the correlation matrix on a heat map. We can derive the following insights from this correlation matrix. The first one, there is a high negative correlation between survival and sex. You see that? You got the survived and sex. It's minus 0.54. And survived is not linearly correlated to age and siblings and Parch. Lack of linear correlation doesn't cross out the hypothesis of non-linear correlation. That's what the most important one. Okay. Then ticket class is highly correlated with the fare. A first class ticket is more expensive than a third one. Obviously that makes more sense. So its P class is minus 0.55. So a first class ticket is more expensive than a third one. Okay, so that's the reason you got a good amount of negative correlation, and this is how we visualize the correlation coefficient matrix using heat map. So now let's take an example. Let's plot it on let's plot it. So to visualize correlation matrix. Okay, so let's take the it's time to call upon the data sets. So we have our data frame ready. Now it's time to import a respective libraries and modules. So first let me import matplotlib. That's the minimum requirement. Matplotlib.pyplot as plt, and I also require seaborn as SNS. So these two has been imported. Now it's time to make a correlation coefficient matrix heat map. So let's create a heat map. So for that I am gonna say SNS dot heat map, and this gonna take data frame first, correlation coefficient mat, then annotation is true, then color map. I just want to show the color map. Let's select the cool color map of cool warm, and that's it. And here and here it is. Okay, you can clearly see with the color map and with the annotation. Okay, so let's simply put let's set plot title. So plt dot title, that is correlation matrix heat map, and finally display the plot. So plt dot show, and here it is. All done, all set. So found out the average orange color, and you have a 0.55 positive, moderate positive correlation, as well as oh, moderate and high negative correlations also, you can clearly see. Okay, now let's do it for the other data frames, because we have made data 2 and data 3. So 2 3, so let's make it into small data frame. Let's slice it, the big data frame, into small ones so that the visualization would be very clear. So correlation coefficient mat matrix 2, and let me plot it, and here it is. It makes more sense. Okay, let's see the highest. I don't find uh, a positive correlation with very good strength and a negative correlation with very good strength. I can only see minus 0.2 to the negative, the highest side. Okay, we can't do much. Okay, so there is not much of negative correlation as well as not a good amount of positive correlation. What you see is all fair amount of positive correlation. So let's go for the third one, and let's see what's there in between that. And yeah, it makes some sense. Here you can see that you can see a pretty strong correlation between alcohol and density. You see that alcohol and density, you got the minus 0.69, though it's a negative correlation, but it's pretty strong. And positive side, I'm looking for only 0.44, 0.44. So that's the maximum side and positive correlation. And that too, it's between quality and alcohol and quality. Obviously, that's a same one, a combination. It's just a permutation of it. So now what else we have? Here we have minus 0.69 that we have seen, and that's it. One minus 0.69, and rest all we don't find a strong correlations. Either it could be positive or negative. Rest all very low correlations or no correlation at all, and that's how we explore. That's how we convert a correlation coefficient matrix into a heat map, so that intuitively we can make a decision out of this. Intuitively we can get it at uh, which variables or which features, basically which features are correlated.